Alright, so today we're going to talk about how to solve a system of three variables using row elimination. Now, the way you do this is you want to eliminate your variables. Elimination, as you learned in Algebra 1, is when you add two rows together and the variables cancel out. And you want us to do this as long as it takes until you get one variable equals some constant. So, the way we do this is I'm going to arbitrarily call these R1, R2, and R3. So row 1, row 2, row 3, okay? And we want to eliminate one of the variables. Now the way I do this is I look at R1 and R2 first, and I try to eliminate something out of there. So if you look at these two, you see that the z's are perfect because it's plus z minus z, which equals 0, which means z cancels. So I'm just going to do that. I'm going to go R1 plus R2, okay? So I get, I'm going to write them out, 2x minus 2y plus z equals 3, and 5y minus z equals negative 31, and add them together, okay? So notice we don't have an x in the second row, so that's just 0. So 2x plus 0 is 2x. 2y plus 5y equals 3y. Z minus z is 0, and that equals to negative 28. Okay? So now I'm going to call this R4. Okay? Now, the next step is you look at row 2 and row 3, and you do the same thing that you just did. Okay? So now, but since you picked z for the variable, you have to go again with z. So therefore, if you look at the z's in R2 and R3, we see that this is negative z, this is plus 2z. So, okay. We have to multiply this row by 2, so that we get 2z, or negative 2z, and that cancels with positive 2z. So if we do that, I'm going to write it out. 2r2 plus r3, which means 2 times the row 2 plus row 3. So now, that gives you 10y, remember we're multiplying by 2, minus 2z equals negative 61. Okay? R3 is x plus 3y plus 2z equals negative 21. Together, that is x plus 13y, this cancels again, which is good, and negative 82. Okay? So now I'm going to call this R5. Now, if we write R4 and R5 over here, we see that this is now a system of equations that has two variables and two lines, which is good. Because what we're going to do now is we are going to solve for the last variable, or eliminate the last variable, that is. Now, since this is 13, this is 3, they don't really go together nicely, but this does. You have 2x and you have x. So the way we do this is we could divide this one by negative 2 or multiply this by negative 2. I'm going to go ahead and multiply the second one by negative 2. So you get over here R4 plus negative 2 times R5. Okay? So you would get 2x plus 3y equals negative 28. And you will get negative 2x minus 26y equals positive 164. Okay? So now again add them together. And these cancel. And you get over here, you get negative 23y equals, that is 136. Yeah. Okay? So now you just solve for y. That means that y is equal to negative 6. Yeah. Okay? So now you solve for y. Now you go back into either these two lines or these two, any one that where you had two variables, since you only have solved for y right now, and you can plug it in. So you have y equals negative 6. I'm going to go ahead and plug it in the top first one. So 2x plus 3 times negative 6 equals negative 28. Now, 3 times negative 6 is negative 18, so 2x minus 18 equals negative 28. Add 18 to both sides, you get 2x equals to negative 10. And that means that x is equal to negative 5. Alright? So now we have 2 out of 3 variables. Now we can go up to any one of these and plug that in. You could technically go for either one of them, but because I don't even have an x here, I'm just not going to bother. I'm just going to go right here. I'm going to plug it in. I'm going to get 5y, which is negative 6. So 5 times negative 6 minus z equals negative 31. 5 times negative 6 is negative 30. Minus z equals negative 31. Plus 30 is negative z equals negative 1. So z equals 1. Z equals 1. And those are your answers. Now if you want to check your answers, you can plug them into all these. And if all of them are right, the system of equations is solved. Okay? Have a good one.